So now that we have some knowledge of SketchUp, we've been able to mess with it, we've been able to make things with it. Now we're going to go ahead and use an extension. The extension is MS Physics. MS Physics allows us to be able to manipulate objects and be able to make them interact with each other. And we're going to be able to kind of roughly create some like kind of interactive machine components and stuff like that, so that then we can eventually try to get it to look like a Rube Goldberg machine. Now that's not the only reason why MS Physics is around. It's also around for simulation and stuff like that. But again, we can take advantage of the plugin to be able to simulate a design, a Rube Goldberg design. So let's get started. Now SketchUp is a program that you can just pretty much model anything. You can draw anything, you can draw stuff. And a lot of times that's it. That's all that you can do. But there's a lot of things that are what are called plugins, where advanced users or people that know coding and stuff would be able to make things that you can utilize. So someone actually made something called MS Physics, and he made it where that you can actually model things, and those things would interact with other things. It's very impressive what he's done, and it's free. It's available so that you can use it, and there's tons of plugins for SketchUp. And so that's a whole, you can spend all day, a couple days looking at all the different plugins and learning how to use those plugins. So like you would model a sphere and model another sphere, and those two things would interact with each other. So it's really cool the way it works. And you'll see in some of the examples that I'll show you that how it works and how it performs. And so, and you'll be like, oh, I can try this and I can try that. So just have fun with it, because I did. Okay, hi. So what we see is right after we've uploaded the MS Physics, the plugin, is we're going to have some extra menus inside of SketchUp. And it normally should be 3 menus. You're going to have one that's called MS Physics Joints, MS Physics Replay, and MS Physics. And if you don't see these, which you should see them, and if you right click on one of these little tabs, or one of these little menu boxes or something like that, if you right click on it, you can actually come here and turn it on, where you see MS Physics, and you get the check mark and you put it on there so you can visually see it. So let's move this one over here. And the replay, we don't need it for right now, but the one we're really be concerned with at the beginning was going to be this MS Physics, just basic MS Physics. And that's where you're going to add properties to some of your objects. And so I have this little this object right here, comes, like I said, with your template. It comes with the file, and we're going to delete them in a second, but I'm just going to create a sphere so that you can kind of see how we create a sphere. And again, that might have been shown to you before, but this is a faster way that I found out discovered. And so I initiate the circle command. I make sure I hit my arrow keys to tell what plane I want to work on. So right now I want to work on this plane, and I draw 2 intersecting circles. So if I use this follow me command, and like I said, first thing I'm going to do is highlight the profile or the path, and that's what this outer circle is the path. And then select follow me, and then select the circle. And there is my sphere. Now, I didn't put any dimensions on this yet, but I mean, we're just kind of basically just kind of drawing something to see how it's done. And then I'm going to use the selection tool to select that profile, which is the path, and I can delete it. And I'm left, and I'm left with the circle. I can also have to delete the path, but it's nothing but a sphere. So now this right here, like I said, nothing has been applied to it for physics-wise, and you'll see a reason why or what in a minute. But it has to be, to work in the physics world, it has to be made a component. But like I said, we're going to draw another component. Essentially, I'm drawing a ball that's going to fall into like a cup or something like that, or a box, whatever. And you'll see what I'm talking about. So I can click on this and I can go ahead and delete him because I don't need him now. But I'm going to select the rectangular tool. And like I said, if you use the arrow keys, you can select what plane you want to work on. See how it's changing a little bit? But obviously I want to be on the flat plane, or this plane right here where these two axes, the red and green one, intersect. So I'm just going to pick from here to here is going to be the profile that I want to draw. And then I can push pull and give it a thickness. Okay. I'm going to center. I'm going to hit H. That's going to allow it to, kind of, I can pan around. I can do it. Now I'm going to draw a line on the top. See, I click on the line and I'm going to pick the end point, the corner right here. And you see that it highlights, and I'm going to pick the opposite corner. Now, why am I doing that? Is because I want to kind of center another rectangular cut within this. So if I highlight again the edge of the line and highlight the other edge right here, it's pretty centered. It's not totally centered because I haven't put any dimensions on it, but it's pretty rough to what I want. So let's go ahead and erase the line because we don't need it anymore. And then now I'm going to push pull that profile. I can either go up or I can actually go into my part. And I'm not going to go all the way through. Again, there's no dimensions to this. And you see that now I have a box with it's hollowed out a little, and I have a ball. Well, the one thing too, if you realize that you got to add physics to this, you got to add properties to this. If I was to hit, like right here, this is a play button. This is a button that you can start your simulation. If I hit the simulation button, nothing's going to happen because these haven't been added as any properties of physics, meaning they haven't been made components. Nothing's been done with them. They're SketchUp parts, but they're not physics parts. So what I have to do is I have to, again, using your selection tool, highlight the sphere, and I have to come here and make it a component, or you hit letter G. And now that is a component. The same thing with the box. I'm going to put a selection tool around it, and then I'm going to hit G, and it's going to become a component too. So let's go ahead and center it on the screen. So I have these two things here, but look what's also going to happen. This is, if I hit the play button, what are they going to do? They're just going to fall. Now they're going to fall with the properties of physics. The regular, the acceleration due to gravity, the falling, is that they're going to fall down as if they're free falling, meaning they're being dropped down. But there's nothing there to stop them. And so what I need to make is, like, imagine I need to make a floor, and a floor that they actually will sit on. So first thing I'm going to do is I'm going to go ahead and move this ball. I'm going to use the move command, and I'm going to select the ball, and I'm just going to move it up. Now again, you'll see it snapping like crazy, but if you're a little patient, you can actually go across up the z-axis. You can raise it up. See, X is, it says, assume that X is the red, green is the Y, and yellow, blue will be the Z. Okay, see, it's moved up a little bit. So I'm going to draw another rectangle here to here, just arbitrarily, where we're picking arbitrary points. And then I'm going to give it a thickness, but I'm going to go in a different direction. I'm going to push pull it, and I'm going to go down. Alright, so that is also itself. Now I need to make it a component. I need to highlight it, and then I need to go to G, make a component, and that's its own component. Now, if I was to hit this play button again, they're all going to fall at the same together. But to make it stick, or to make it stay, I have to make it what's called static. And in MS Physics, that's what it means. It's static. It will not move. So if I right click on it and go MS Physics, the state of it, and there's all these different states you can do for your different parts, is the one I would pick is static. So what is that going to do? That's essentially going to make it a floor. Now remember, when I extruded down. I didn't extrude up, because then it would be extruding to the little box part with the hole, with the cavity in it. So I had to go down. And let's see what happens when I do that. You see that it's static. It stays in place. The box sits on top of it, so the box is not going to drop down anymore. The ball dropped down and hit the edge of it. So let's see if I can get the balls inside of here. So what I need to do is now move the ball. I'm just going to pick the ball, and I'm going to use the move command. And I'm going to say, okay, and I can use geometry, like I said, geometry on a part that I just created. Here to say, maybe to there. And again, move it. And I recommend that when you get used to doing this, you'll be a lot faster. But this is our first time doing this. And let's say to there. So I take advantage of endpoints and things that are on other parts if I need to. Much more complicated drawings, and people with a lot more experience with modeling in this, they do things a lot easier. Okay, so the ball is over the hole, and let's see what happens. Play, and it drops down, but it doesn't go inside because it's still being treated as a rectangle and not a rectangle with a cavity. What you have to do is you click on the box, and you have to change a property of the box further. I mean, this is why MS Physics is very involved. There's a lot of work in MS Physics to try to figure out how to do something. So let's say I have to hit this little UI, which will give me the where I can change the information about a part. I can change material. I can change how it's going to react to other parts. There's a lot of things I can do. But one of the things that I can do too is I have to say that it's a static mesh. And what it's going to do, it's going to take in consideration that hollow or that cavity inside of it. So now if I go ahead and I hit play, it's going to drop on the inside. And that's the only way right now that I found that it'll work, that the ball will actually go inside. It has to be a static mesh. But what if I add more balls to this? So you see you have this ball right here. So if I was to kind of go, and that's a component, remember it's a component. So if I was to come here and let's say move, I click on the ball. Now if I hold down the control key, it's giving me the option to make copies. And you see, look at the little rubber band. The little rubber band changes color if it's on the axis. So I click on there, and then I have the option, and I can go, hit tab. I have the option, and I can type in 3x. What it's doing is whatever distance I had copied it at, it's going to now use that distance and make me 3 more copies. The original, and then 2 more copies. That's the 3. And let's say I want to be a little bit more adventurous. If I hold down the control key, because that means it allows me to be able to select multiples. Control key allows me to be able to select multiples of those. And let's say, let's go ahead and copy or move. We're going to move. But I'm holding down the control key because I want to copy these. And I'm going to go up. Realize my axis right now, see it's rubber banding or automatically selecting the axis. And see it's lining up with the axis. And I select there. Hit tab, and then I can say 3x. And that's 3 times that. So there's 2 more lines that have been created with that. You see all those balls there, they're components, so they're going to react to the physics. Now if I wanted to, I can come here into materials, and I can maybe be able to select like a color, and then I have an option I can paint them. And then, I don't know, let's select another color here. Let's select like yellow. These here will be yellow. And then maybe these here will be green. And that little paint bucket, I'm highlighting the paint bucket, and the paint bucket will allow me to be able to, when I select the object, it will change the color. So, I mean, like even the box right here. Let's say a brown. And I come here, the paint bucket is highlighted because it knows that's what I want to do. And I highlight the box, and the whole thing turned brown. And it's a little dark. Let's go in lighter. And then maybe the floor needs to be dark. So we kind of made this with pretty colors and stuff, and it will be a little bit easier to understand when we do it. Is right now all these boxes are kind of suspended in the air because we haven't initiated any physics yet. We've gone back. This is like the starting point. So and I'm going to move all these balls over just a hair. So again, you can put a window around. Oop, not that way. Oh, I have to use the selection tool. Select. You can hold on to the control keys so you can select multiples, or if your window fits them all, then it'll highlight those parts. Now I'm using the control key to make sure that I can select those too. So I've selected all these. Now realize too that you can also make these a group. So, but they're all highlighted. And let's move them. Let's say we have to move M, or we can highlight the little the little command, and we want to move them from that endpoint. I don't know. Let's just say right there, and let's see what's going to happen. So now they're kind of we've eyeballed it. We don't have exact numbers or something like that. But let's see how this is going to go ahead and drop for us. And we're going to hit the play command. And there it goes. And this right here, you know, once you're done with your simulation, you reset, you go back. Now, one thing too that I found out, or one thing that too in doing this, is sometimes that gets grayed out, and you're at the point where everything is reset, so is not set. So make sure that you save it before you actually simulate it. So in case it you can't able to reset it, you can be able to reopen the program and mess with it. One thing too is like once you do your simulation and realize the simulation, you know, it's good, it's real good, but they always kind of fall in the same place. So you see those three balls? Now there's no effects that are changing this. There's no wind, there's no this, maybe there's weight or something like that, but pretty much just for it to run, it's all kind of like generic and all stuff like this. If you were to change properties and do stuff like that, it's going to be changed. But I mean, it's pretty impressive what you can do. You can set up something that is really neat, a process that goes and controls these parts in different ways. And like I said, I hit the reset, hit play, and then I hit the go back to the reset. So I started new, and maybe I can change this. Maybe I can modify something. Now, one thing you can also do too, you know, like I said, we have shown you, is that when you hit play, you can go ahead and even grab a part and move it around if you wanted to. And see, it's hitting that wall. It's on the floor. If I tilt it, get it to the edge, it's going to fall. And even these balls that are in here, I can do something with them. See? Just making them fly off. I'm picking it up, dropping it, picking it up and drop it. Now, obviously, the box, I can't pick up and drop it because it's static. And see, I reset the whole thing, and I'm back to where I got to go. So, I mean, that's one of the cool things in the introduction to what MS Physics can do. Now, that's one force where that everything drops related to gravity. And they do collide and hit each other. I mean, if I would say I was to move the top row, just the top row, this one, hold down the control key, oops, yeah, this one, oops, okay, escape. Well, let's just select them first. Always good to select first. And then move from that midpoint. See, it'll automatically find the midpoint for me. And go to there. So those balls are slightly moved or slightly at a different axis. And actually, I think I copied one by accident. Oh, well, let's leave it there. Let's see what happens. Okay. So you see, that's a really cool what you can do. And you can really mess with things and different shapes and different things like that. There's a lot that can happen for you as far as what MS Physics can do. And then the next process that I'm going to show you is how you add actual forces to some of your objects and make them do something. And that's also, like I said, that's a lot of work. I mean, we're going to talk about just some basic ones, but some of them can be very complicated. And like I said, it's pretty fun. You can kind of watch this stuff for a long time and go, oh, this is different. This is cool. And it is. So, all right, enjoy and try it out. Now, if we take a look at some of the forces that are available in MS Physics, I mean, there's just so many. And like gravity is not the only thing out there. When objects fall and they collide against each other, that's something. There's something happening. That's mainly the most basic one of all is the gravity of objects falling down. But you also have the ability to make objects do something. And some of the built-in forces that you see are like here shown is like hinge, motor, servo, the slider, the piston, the up vector, the spring, a corkscrew, ball and socket, all those curvy things and all this kind of stuff make objects behave a certain way. Now, it takes some knowledge about this to be able to make them do what you want. So it's not an easy thing that you're going to just learn in a few minutes. You have to understand the basics of physics. So you can see from this, this is something I downloaded off the website, but you can see that it's like essentially like a whole bunch of dominoes lined up, and they're like on 3 separate platforms. Yes, I know they're kind of suspended in space, but they're static. They're not going to move. They're not going to fall down when I initiate the physics on it. But you will have that one on the top left, that one domino that will fall over and start to knock the other dominoes down. And as you can see, it's falling over, and now they're going down and knocking the other dominoes down, and it falls to the next level, and it knocks those dominoes down. And then down to the bottom level, and it hits those. So you can do something real kind of creative like this. You can figure out how you can use that in your machine so that it will actually work or do something pretty cool. And like I said, the copy command or like the move command, when you move something, you hold down the control key so that you can copy it, and then you can specify it'll use the same distance over again if you actually type in like 7x or 6x or 10x or 20x, and then you manipulate the objects to kind of do a curve. Now in this example here, it's just a simple example of the fact that all those discs are sitting on top of that base, and so the car is made up of some of those discs and also made up of its own shape. And then you can actually kind of run the car into those other discs, and then like pretty much you're just plowing them down or knocking them down. Yeah, and the car kind of jumps around too a little bit because, again, not all the properties have been made to make it act like a car. And the car falls off the base when it runs off the edge. So that's kind of a fun example of what you can do with the physics. It isn't all like you have to analyze something and do something. You can actually make something kind of fun. And this here was another example of like a ball hitting a wall. And so, and then it also, like I said, we're taking care of gravity with those balls or those squares falling. That's gravity and being collided. But you also put, like right here, you put this hinge. You put this ability for a hinge, and the hinge is centered on that rectangle, which then has a long piece that's going to the ball. And so what it does is it fixes it in place, but it will kind of rock around that center point, a hinge. And so then you pull back the ball and you release it, and it's going to fall and hit those blocks. So I mean, yes, it's like I said, it isn't perfect, but it's pretty cool that you could actually simulate something. You could simulate something hitting or other objects hitting something else. And the next example will be a little bit more complicated line or an actual chain that connects the ball to the hinge point, and then you're using a more complicated physics joint. And so it's really actually, they modeled, instead of it being like a solid string attaching from the hinge point to the ball, it actually is a chain, and the chain will behave and act and work together. So it actually is kind of somewhat a little bit more realistic. So it's pretty neat what it can do. Oop, I went back for some reason. I went back to this one. So, excuse me, it's a second of that. Okay, there we go. And so as you see, the chain links are modeled. And they're modeled individually. Like I said, they're all components for themselves, so they'll behave together. And they're using the socket joint, so that they can be able to work. They can work like a chain when you activate the whole thing and drop it. And so, like I said, the gravity is going to pull on the block. The one point is fixed, and then it's going to come down and hit that wall. And the wall, like I said, is made of separate components, separate blocks. And so when it is hit by the ball or hit by the square, it's going to come and go, break apart. And see, there you go. So like, for this something to be, that you can download for free and mess with for free, it's pretty cool. I mean, you can do a lot of kind of simulate. You can record this. You can put it into a video, and you could even add sound to it if you wanted to. So I mean, obviously, it helps to obviously have a good computer, good strong computer that can be able to handle all this computation, because there's a lot of computations that are going on. And this is also, like I said, this is an example of gears, maybe a gear system that goes around a shaft. And like I said, that's what these here are, and these go ahead, and these are they're rotating around the center of the gear, and you establish that when you go ahead and place down this physics constraint. You're constraining the geometry and making it do what you want to do. And you see right now they actually have timed it. And on the bottom right, what you see is there's a slider. The slider or a little thing that you can control the speed with of how you want these things to interact. So it's pretty cool. I mean, pretty cool. I mean, it helps that your background or your knowledge of gears and things like that you can be able to use, because then you can apply it to what you model. So that's just that's pretty neat. And this one right here is kind of like a clock, or kind of again, everything is off the center. Is that those center little physics joints are allowing this whole mechanism to work. And so you don't have to design or build an entire mechanism, but you can kind of show maybe like a principle of the mechanism that's working, or how it's behaving with the other ones. And you see it's kind of like ticking. It's almost like it's like a clock. It's kind of moving along. So like every rotation on the inside is causing the outside rings to go. So it's pretty cool. It's pretty neat what you can do. And this is, like I said, it's a free program. And it's a lot of your creativity and your ability to be able to model and stuff like that. You could actually apply something that's pretty cool. And I like the way the designing is really neat, as far as like the colors, the properties that you can place onto it. And like I said, on the center of this is actually also, like I said, one of those circular constraints that is governing that part. Now that part is an individual part. It's been modeled as an individual part, but maybe some of those things have been grouped together to make multiple parts into one part, and how they behave. And you see the wheels in that little cart on top. They also have a motor constraint on them that's making the entire thing turn. And what's governing that large wheel in rotating is also the fact that it has a center constraint on it. And so just real quick, to be able to do a simulation, which is really nice. I mean, there's other much more expensive CAD programs that let you do. I mean, they're doing the design work, they're doing, you know, the drawings, they're doing all this kind of stuff. But when you need something just to kind of show something or animate something, this is where SketchUp really, really pays for itself. It really is really a neat program to use. So you see the little car is moving, and it's causing the bigger wheel to spin. And so that's, again, it's very useful. And this one here, I when I was doing research and stuff for this program, someone had simulated this little, it's like a little mannequin dummy. Normally artists use them a lot when they kind of draw figures and stuff. But he's on a bicycle, and they've actually been worked on to constrain it so that when he's pedaling the bicycle, he can actually even lean. His seat position can be changed. There's a little bit of coding and stuff involved with this. I mean, see how he's teetering, he's moving from side to side. Like I said, you can change the seat position to see how it fits, and then you can actually then, like if he's pedaling. So it's pretty cool. It's pretty neat what they've done. It does require, like I said, you do have to know a little bit about coding, and it's a little bit tougher. But you can see where all this leads. It may lead to the ability of maybe doing some kind of 3D animation, 3D simulation, stuff like that. So very, very useful on what it can do. And I reset the simulation so I can be able to change the angle or do something like that. So now, so like this right here, which is a simple thing that I'd modeled. I modeled, like I said, the base right there. It looks like a pan, but it's the base. And then I have this little tooth, and on the tooth I will go ahead and add a motor constraint, and the motor constraint will then govern how it turns. Now, I have to sit there and grab it and move it. But as you can see right there is a toolbar. The toolbar right there has all the different constraints on it. And like I said, if I was to be able to do this talk, it would be hours that I would talk about all the individual constraints. So it's something that's a lot of work. Not really a lot of work, but it's very easy to do. So I'm showing you right now how I added that in. So I'm concerned, I want everything to rotate around the center. So when I click on to add the constraint, I have to select the center. I mean, I can select an edge. I can select other things too. So I select the outside of the circle, and then I go to the other side and select the outside so I can automatically find the center. And so when it's placed, there it's placed, and now it has a constraint. And so, yes, until I actually tell it that I want that constraint to go with the part, it's not going to. You see how it dropped down? It dropped down because it doesn't have that constraint. So now I have to go to the command, the first command right there, click on it. And then when I click on the constraint, then I hold down the shift key or control key, and then I select the object. Remember, the object has to be a component. And I click on it, and now that's added to that particular physics function. So when I hit play, it's now going to take the properties of that motor rotation and now can rotate. So, and then see, it doesn't drop down on the pan because it has a constraint. It will be fixed in place, and all it will do is rotate. So it's pretty cool what it can do. Pretty neat that it has that ability. So, and it's one of those things that you have to kind of sit there and play with it. You have to sit there and mess with it, and kind of you come up with your ideas. And what I did right there is I didn't delete it. I did not erase it. On the constraint, the purple thing. What I did is I went ahead and I hid it so that you can just be focused on the actual objects and your simulation. So when MS Physics places it in, it kind of like places it in as a large object. And then you can click on it, right click, and you can say hide. It's still there. You can unhide it. You can do stuff like that if you want to see it. So I created this little simulation because I was experimenting with something. I was experimenting with I wanted to see how something behaved and stuff. And I wanted to really, the ball's going to fall. It's going to be hit by a piston, and then it's going to fall onto the track, and then it's going to hit that one little wheel that's being ran by the motor. So And it was just a little experiment. It's just and the tracks are kind of angled, so the ball will gravity wise will come down. So right now at the beginning of my simulation, it's suspended. So when it falls down, it's going to fall down in that little hexagonal cup, and it's going to be held in until with the piston I can say pop it in, pop it down the rail, the track, and then it'll go to the other track, and then it will go down. So I start it, the ball's going to fall, and see on the bottom right I have an actual, like I said, a dialogue so I can tell it, like a pinball machine, I can just whoop, hit the ball. See, the ball drops the other one. Yeah, it's going to fall down, but it runs on that little wheel, and then it drops down. So it's an experiment, and like I said, I done many of these to be able to test out my ideas and stuff like that. You get really when you take a look at the warehouse, when you look at all the different problems that people, and if you look under MS Physics, you'll find a lot of stuff that people have done, and you're going to really be impressed with the amount of work. And like I said, some have incorporated coding, some have incorporated a lot of different concepts and to be able to solve their problems. Again, the ball falls, goes down the track, hits that. And like I said, I could the blue thing, which is, like I said, which is telling me that is a certain action. I can go ahead and hide that. I don't need that anymore. And see, it hit the ball a certain way where it's just kind of going back and forth. And that was the one thing that I noticed about this is a lot of times the simulations will be the same. So I'm trying to incorporate some kind of variability in them. And this here is just to show that this here, imagine it's reading information from my mouse. So from my mouse, it's reading the actual position that my mouse is at. And it's actually reading the buttons that are clicked and even the wheel, the mouse wheel. So I know it doesn't look like much, but it's bringing in that information. And then it's relaying that information for on the screen. There's some of the coding that is reading in. Now that's really complicated. Even for me, it's very complicated because obviously with coding and stuff like that, you have to kind of learn. You kind of have to, experiment and take time to really master it. But just to kind of show you that such thing does exist. I mean, I'm hitting my mouse wheel. I'm moving the mouse in the button, the little wheel in the button. I'm hitting the two left keys or two keys, the three keys on the mouse, and you see that it actually is reading that information. So it's pretty cool. It's really neat, and you can even go even further with this stuff. So your imagination is there. So I know for right now, it's just you're going to probably end up simulating something very simple, something very basic, and that's perfectly fine. But realize you can go even further with it, and that's all. As you get further into classes or you get further on assignments, realize that this is something you can do. And like I said, the physics constraints are, like I said, motors and servos, all those just kind of the basic ones. There's a lot more that you can be utilizing. And so just kind of experiment and play with it. So, yeah, I mean, I hope this was helpful to you. I hope that it kind of helped along with showing that you can actually do something and you can model something. So it is interesting. Like I said, then I'm showing right there, I'm clicking on the different examples to show that those are groups. They're behaving as a group together. And so you added the constraint. So as you can see in the Rube Goldberg that I made, or the design that I made, there was a few times when I was experimenting, kind of trying something out. None of this ever works perfect. It's always, when you're working with design software or something like that, you have to kind of, it's just like being outside with trying to mess with something, trying to get the domino to fall right, trying to get something like that. So it's always kind of, it's just, the difference is you're in front of a computer as being outside with, or in a lab with your stuff. I mean, you can model things like this, model the balls, and they can interact with each other. but you have to kind of anticipate. You kind of have to take a look at how things are going to happen. And so how, like, say, for example, you have the dominoes, and the dominoes are going to hit each other. So, yes, I mean, it's one of those things that, again, the success in seeing it work, that is that's the award, that is the accomplishment of seeing the Rube Goldberg happen. And so it's always like, it's a challenge. And normally people that are like really into engineering or really into something like that, they want to be successful. They don't want to fail. But you're going to do it a few times. That's realistic, is you're going to do it. Because I did it too. Trust me, when I did Rube Goldberg, when I was taking intro engineering classes, plenty of times that I failed until we finally got it to work. So enjoy making this. Have fun with it. Challenge yourself. And just overall have fun.